Hello everyone. Welcome to today's session, where we'll be exploring the fascinating world of combustion and flame. I'm excited to go on this learning journey with all of you. Let's start with a quick question to get us thinking. What do you think makes it possible for a material to catch fire and stay burning? I hope you're all coming up with ideas, maybe talking with your classmates or writing down your thoughts. All right, keep those answers ready, because as we go along, you'll see if you were right. Let's dive into our chapter. This chapter is divided into three main parts: combustion, flame, and fuel. Each of these plays a big role in helping us understand how things burn and the science behind everyday fires. But for today's lesson, let's focus on just one part: combustion. So, what exactly is combustion? Combustion is a chemical process where a substance reacts with oxygen from the air and produces both heat and light. It's one of those fundamental reactions that we can actually see in our everyday life. For instance, let's take the example shown in the image. When a strip of magnesium is burned, it reacts with the oxygen in the air. What happens next is quite amazing. You see a burst of bright white light, and you can feel the heat coming off as it burns. This is a clear demonstration that combustion doesn't just produce heat, but also gives off visible light. Substances around us fall into two categories when it comes to burning. Combustible substances, these catch fire easily. Non-combustible substances, these don't catch fire easily. Now, let's explore what these really mean. Combustible substances are materials that burn easily when exposed to a flame or enough heat. You can think of things like matchsticks or paper. They almost seem like they're waiting to catch fire once you bring a flame close. Other examples include coal and petrol. Non-combustible substances, things that just don't catch fire no matter how hot you try to make them. Imagine bricks, iron nails, or even glass. Have you ever tried to set fire to a brick? Of course not, because it simply won't burn. These materials are often used to keep fires contained or prevent them from spreading. Let's talk about something really interesting: oxygen and how important it is for things to burn. Whenever you see a candle flame, remember, it's only possible because there's oxygen in the air. Imagine lighting a candle in your room. It glows gently and gives you warmth and light. Now, if you carefully place a glass over that candle, something surprising happens. At first, the flame may flicker and struggle, and then, poof, it goes out entirely. Why does this happen? The candle uses up the oxygen under the glass, and once there's none left, it can't keep burning. It's a simple experiment you can even try at home, with an adult's supervision, of course. This neat trick shows us that oxygen is like food for the fire. Without it, even the hottest flame can't survive. Whenever a combustible substance, which just means anything that can burn, like wood, paper, or petrol, comes together with oxygen from the air, and a little heat gives them a boost, a reaction starts. This reaction is called combustion. The result? We get heat and light. That's why you feel warmth from a fire and can see a flame, because that burning chemical reaction is releasing energy in the forms of heat and light. Now, let's go a little deeper. Combustion isn't always the same. It actually comes into types: complete combustion and incomplete combustion. When there's plenty of oxygen available, you get complete combustion. Here, the material burns thoroughly, and you get a clean, hot flame with hardly any smoke. For example, think of the blue flame on a gas stove at home. That's complete combustion at work. On the other hand, if there's only a limited supply of oxygen, then incomplete combustion takes place. Now, let's understand what inflammable means. Inflammable substances are those that catch fire very easily because they need very little heat to start burning. Think of LPG, gas canisters used for cooking. Petrol. Hydrogen. These must be handled with extreme care because even a small spark can make them burst into flame. To start any fire, you need three golden ingredients, like a secret recipe. The first one is fuel. This is the material that burns: wood, paper, a candle wick, or even gas on your stove. Without fuel, the fire has nothing to feed on. Second is oxygen, found in the air around us. Oxygen keeps the flame alive. Ever blown out a candle? You removed the heat and some oxygen, and the flame died. And the last one is heat. This is the spark that kickstarts the fire, like a match, a lighter, or even sunlight through a magnifying glass. Without enough heat to reach the ignition temperature, nothing burns. Remove any one of these, and the fire goes out. Now, it's your chance to connect all this to real life. Try and find or remember a story, maybe from the news or your own experience, where a fire started or was prevented. Ask yourself, what kind of fuel was involved? What caused the fire to start or stop? Was it because of fuel, heat, or oxygen? How was the fire controlled, or how could it have been prevented? Thanks for joining me on this journey through combustion and flame.